Good afternoon, everybody. Happy almost 5 o'clock in the afternoon. I'm sorry I've been such a slacker with this video today. I usually try to get it done first thing in the morning, but I spent most of the morning on different calls and meetings and so on and so forth, really testing out that new digital meeting technology, you know. Anyway, I hope everything is going well with you guys. Not a whole lot to report on the old home front here, but I was talking to a friend the other day who made a very interesting comment that she wished that we could just all move to some alien planet until the whole COVID situation passed. Which brings me to today's fact of the day, the Fermi paradox. This one is one of my favorites. It is kind of a long, in-depth topic, though there's a lot that goes into explaining exactly what the Fermi paradox is. So I'm going to do my best to keep it short. I know I took like 16 minutes on my video yesterday, which was probably a little bit long. These were meant to be like little clips. So I'm going to try to keep it at around 10, but we'll see how it goes. And we'll start back at the very, very, very beginning. So a really starry sky seems vast, but realistically, all we're looking at is our very local celestial neighborhood. On the very best nights, we can usually see about 2,500 stars, which is roughly 100 millionth of the stars that we have in our galaxy, and almost all of them are less than 1,000 light years away from us, or about 1% of the diameter of the Milky Way as a whole. Now, what we're really looking at is this. As many stars as there are in our galaxy, which is about 100 to 400 billion, rough estimate, there are roughly an equal number of galaxies in the observable universe. So for every star in the Milky Way, there is a galaxy somewhere out there. And altogether, that comes to the typically quoted range in the science community of between 10 to the 22nd and 10 to the 24th total stars, which means, in kind of a more picturable platform, it means that for every grain of sand on every beach on planet Earth, there are 10,000 stars out there, which is a lot. Now, science isn't in total agreement about what percentage of those stars are sun-like, so similar in size, temperature, luminosity, intensity as our own personal sun. Opinions typically range from between 5% and 20%, going with the most conservative side of that, 5%, and the lower end for the total number of stars, which is 10 to the 22nd. That gives us 500 quintillion, or 500 billion sun-like stars out in the universe. Now, there is some debate as to what percentage of those sun-like stars might be orbited by Earth-like planets. One with similar temperature conditions, could have liquid water, potentially support life, have breathable air, things like that. Some say it could be as high as 50%, but we'll go with a more conservative 22%. That came out in a PNAS study not too far back, which suggests that there's a potential habitable Earth-like planet orbiting at least 1% of the total stars in the universe, which is a total of 100 billion Earth-like planets. So there are 100 Earth-like planets for every grain of sand on every beach on planet Earth. Think about that next time you're at the beach, because dang. But from there, moving forward, and I promise I'm going to get to the Fermi paradox here in a second, but this is important background information for you. After that, we have no choice but to get 100% like speculative, but let's imagine that after billions of years of existence, 1% of Earth-like planets develop life. So using the same beach analogy, that would mean that every 1 grain of sand on every beach on planet Earth would equal 1 planet with life on it, 1 Earth-like planet with life on it. And then imagine that 1% of those planets, the life advances to an intelligent level like it did here on Earth. That would still mean that there were 10 quadrillion or 10 million billion intelligent civilizations in the observable universe. Now, moving back to just our galaxy, shrinking it in a little bit, doing the same math lower on the lowest possible estimate for the number of stars in the Milky Way, which is 100 billion, We estimate that there's about 1 billion Earth-like planets and 100,000 planets with intelligent civilizations in our galaxy, just in our galaxy, which is really kind of crazy. And SETI, who is the search for, it's an organization called the Search for Extraterrestrial Intelligence. They're dedicated to listening for signals using these massive radio telescopes of other intelligent life. And if we are right that there are 100,000 or more intelligent civilizations in our galaxy, if even a fraction of those were sending radio waves or laser beams or other modes of attempting to contact others, you would think that satellite dish arrays, things like that, would pick up all kinds of signals. But they don't. They haven't. They never really had. So the question is then, where is everybody? And this is where the Fermi paradox comes in. So where is everybody? We have no answer to the Fermi paradox. The best that we can do is possible explanations. And if you asked 10 different scientists what their hunch is about the correct one, you are going to get 10 different answers. So it's kind of a hot button issue. When you hear about humans of the past debating whether the Earth was round or if the sun revolved around the Earth, or thinking that lightning happened because of Zeus, and they seem so primitive and in the dark because of their viewpoints on that, that's kind of where we are with this topic. And taking a look at some of the most discussed possible explanations for the Fermi paradox, we can kind of divide them into two broad categories. So those explanations that assume that there are no signs of intelligent life because there are none out there, and those which assume they are out there and we're just not understanding or seeing that for any reason. So explanation group one, there are no signs of higher intelligent life, no signs of intelligent civilization, because there are none in existence. Those who subscribe to this particular viewpoint tend to point to something called the non-exclusivity problem, which rebuffs any theory that says there are higher civilizations, but none of them have ever made contact with us because of X, Y, or Z. They tend to look at the math, which says that there should be so many thousands or millions of higher civilizations in the observable universe. At least one of them should be an exception to the rule. If a theory held that 99.99% of higher civilizations behaved one particular way, that is, didn't get in contact with us, things like that, that there should be that 0.01% that would behave differently and we would become aware of their existence. Therefore, this particular group of explanations, it must be said that there are no super advanced civilizations, and since the math suggests that there are thousands of them just in our own galaxy, something else has to be going on. And that something else that they tend to refer to is something called the Great Filter. Now, the Great Filter is, it's a concept that suggests that at some point from pre-life to advanced intelligent civilization, there's a wall that almost all species have a tendency to hit before they hit advanced intelligence. Now, there's some stage in that long evolutionary process that it is unlikely or impossible for life to get beyond. That stage is what they call the Great Filter. So if this theory is true, the big question is, where in the timeline does the Great Filter actually occur? And it turns out that when it comes to the fate of humankind, the question is pretty important, because depending on where the Great Filter occurs, we're left with three possible realities, which is either we're rare, we're first, or we're kind of screwed. We're rare would suggest that the Great Filter is behind us. One hope is that we manage to survive it. We manage to get past it, which would make us extremely rare in the grand scheme of life to have been able to make it to our level of intelligence. But that also means we're special. And if we're special, then the question is, at what step were we able to surpass almost every other organism in the known universe? We don't know. The other one possibility could be that the Great Filter occurred at the very beginning. So the idea that life itself might be very difficult in the first place. So this is a candidate because it took Earth, about 1 billion years for it to finally happen. And because we've tried extensively in the scientific community to replicate that particular initial spark of life in labs, and we haven't really been able to do it. If that's the great filter, it would mean that not only is there no intelligent life out there, but there may be no other life at all. Now, another possibility, the great filter, could be the jump from simple eukaryotic or simple prokaryotic cells to multicelled complex eukaryotic cells. So after prokaryotes came into being, they actually stayed that way for about 2 billion years before making the evolutionary jump to being complex, having a nucleus. If this is the great filter, then that would mean that the universe is teeming with prokaryote cells, which is kind of neat, but very little beyond that. If indeed we are rare, it could be because of a fluky biological event, but it also could be attributed to something called the rare Earth hypothesis, which suggests that there might be a lot of Earth-like planets, but that the particular conditions of Earth itself, whether related to specifics of our solar system or relationship with our moon or our sun, something about this planet itself makes it extraordinarily friendly to life. The next possibility, again, is that we are first. So for this first group of thinkers, if the great filter isn't behind us, then the hope is that we have the conditions in the universe only just recently, for the first time since the Big Bang, that would allow intelligent life to develop. In which case, yes, we may have been the first, but conditions might exist for other organisms on other planets, even on this planet, to eventually follow. So we and other species are continuously making that climb. We just happen to be at the front of the pack. Again, goodness only knows. The last possibility kind of within that group of thinking is just that we're kind of screwed. The great filter is ahead of us and hasn't happened yet. We're not rare, we're not early. It's just the great filter must be somewhere in our future, which would suggest that life regularly evolves to the place that we are in right now, but something at some point prevents it from evolving any or much further than where we are currently. And it's unlikely that we're going to be an exception, which is kind of doomsday-ish, but it is what it is. I'm just throwing all of the suggestions out on the table. Now, there's the second group of people who tend to believe that intelligent civilizations are out there and there are just logical reasons why we have not found or heard from them. So there's plenty of activity and noise out there. There's a possibility there's plenty of activity and noise out there, but our technology is just too primitive, or we're listening for the wrong things. So as an analogy, it's like walking into a modern day office building with a walkie-talkie and trying to contact the people who work in that building with a walkie-talkie. But nobody else in that building is using a walkie-talkie. They're all using email or texting on their phones. But because nobody got back to you on the walkie-talkie, you are just making the assumption that that building is completely empty. It's not valid, you just weren't looking for people in the right way. There's also the possibility that higher civilizations are aware of us and are observing us, which is something called the zoo hypothesis. I don't think that probably requires too much explanation. And then there's the possibility that higher civilizations are here all around us, but we are just too primitive to see them. There's a very famous author, and I think he's a physicist, named, I think it's Mikio or Michio Kaku, K-A-K-U, who had a very interesting analogy about pretending that we are all just an anthill in the middle of the forest, and right next to the anthill, a super 10-lane highway is being built. The question is, would the ants be able to understand what a 10-lane superhighway is? Or would the ants be able to understand the technology and the intentions of the beings building the highways next to them? Would they even be able to comprehend that there was other life building that highway, if that makes sense? So that's definitely an interesting way to think about it. And then the last possibility there is just that we are completely wrong about our own reality, and that we're all going to look back and be like, mess that one up. So, I mean, as we kind of continue along our futile, possibly, search for extraterrestrial intelligence, I don't really know who I'm reading for. Frankly, learning that either we're officially alone in the universe or that we're officially joined by other in the universe is equally creepy in its own particular way. lots of surreal storylines there, and that is why science fiction has the popularity that it has. But whatever the truth actually is, it's gonna be mind-blowing. Beyond kind of that shocking science fiction component, the Fermi paradox is also pretty humbling. It kind of brings out the sharper idea that can only happen after you spend lots of hours researching your own human species, and all of these weird, crazy ideas that tend to contradict each other and overlap each other and remind us that future generations are going to look at us the same way that we see ancient people when they thought that the earth, or that the sun moved around the earth, or that the earth was flat. We're definitely going to look back and be like, wow, those people had no idea what was going on. So we're pretty ignorant in all of this, and that's a very humbling thing to recognize. That being said, I am all for any viewpoint that isn't just that humanity is a lonely orphan on a lonely rock in the middle of a desolate universe, and that we're all by ourselves and don't know as much as we think we do. So here's to hoping that this opens the door just a tiny little crack to recognizing that there may be more story out there than we realize. But yeah, that's one of my favorites. Basically, and I don't think I ever totally explained this, but the Fermi hypothesis, it just surrounds the idea of, if there is intelligent life out there, why isn't that we haven't seen it? It was brought up by a guy, surprisingly, named Fermi, who worked for a huge lab. What was it? I feel like I need to give you guys this proper information now that I've started it. Hang on. Let me try to turn my computer back on. This is going to be a terrible video for you, and I'm sorry. There it is. Fermi. Who was Fermi? His name is... He was an Italian physicist. His name was Enrico Fermi. He's actually very popular. Came up with the first nuclear reactor. This whole kind of theory came up very casually. Actually, it surrounded a casual lunchtime conversation he had back in the 1950s. Where people were talking about aliens, and he's like, oh yeah, well, if there's aliens, where are they? And lots of things have come from it. There's something called the Drake equation, if you're really into science. It kind of puts some mathematics to all of the theoreticals that got brought up here, but it's an interesting thing. It's a very interesting thing. But I want to leave you on a happier note, so I am going to read you one of my favorite quotes. I should have also had this pulled up. I'm really terribly sorry that I'm just the worst at being prepared. I'm also at 18 minutes. I'm really sucking at this. All right. Here's your positive quote for the day. This is again from Bill Bryson, from the book that I was talking about earlier, A Short History of Nearly Everything. But it says, not one of your pertinent ancestors was squashed, devoured, drowned, starved, stranded, stuck fast, untimely wounded, or otherwise deflected from its life quest of delivering a tiny charge of genetic material to the right partner at the right moment in order to perpetuate the only possible sequence of hereditary combinations that could result, eventually, astoundingly, and all too briefly, in you. So, hey, you already beat the odds. Hope you have a wonderful day. See you tomorrow.